Question 2 here. We got supposed pregnancy lengths in humans are normally distributed with a mean of 272 days and a standard deviation of 9 days. The due date for Mrs. Pendleton's baby is February 5th, 2021, which would be a gestational length of 280 days. What percent of pregnancies last longer than that? So this is a normal curve, normal CDF. You want to draw your normal curve, calculate the appropriate boundaries, then summarize your results in context. Always use context when you're doing these. So go back and try this on your own, pause the video, then you can move on once you've tried it on your own. All right, here we go. It's a normal CDF. We're looking for a number above a value. So you want to draw your curve out and label your mean. You can count your standard deviations. You don't need to necessarily make a scale here, but it's not going to hurt. So to get this answer, what we want to do is we want to go into our calculators and we want to do normal CDF. You can do z-scores and tables as well, but I'm more of a normal CDF person. So you do second vars, normal CDF, your lower bound, in this case, since we want to know above 280, it's 280. Your upper has to represent everything above it, so infinity, but your calculator has to do 1e99. So you do 1, you do second, comma, 99. That's the highest number you can input in there. Your mean is 272, and your standard deviation is 9. And so you get a value of 0.587. I had a typo in there. I had a pi in front of it. So you actually get 0.187, which makes more sense. So 0.187, that's probability of somebody having a gestational period longer than 280 days. So to wrap it up, you say about 18.7% of pregnancies last longer than 280 days. All right. All right, part B. What is the probability that Mrs. Pendleton's baby is born before the second semester starts? So in other words, she has a gestational length less than 248 days. Try this one on your own, less than 248 days. So that's a small percentage here. Normal CDF still, but our lower bound is going to be to the left of that. So it's going to be negative infinity. So you want to do negative 1e99 when you're inputting that into lower normal CDF. So let's do that. Second vars, normal CDF, negative 1e99, 248, 272, and 9. And it's a pretty small percent, 0.0038%. So, or 0.0038. So we'd say the probability that her pregnancy lasts less than 248 days is 0.38%. So it's pretty unlikely to have a pregnancy less than that amount of time. Make sure you always summarize in context. Letter C. 5% of pregnancies last longer than how many days? Try this one on your own. Okay, 5% of pregnancies last longer than 286.8 days. Here's how you get that. This is a above problem again, but we don't know the x value, right? We can kind of estimate it somewhere up here, around 290 or whatever. But to get the exact value, we want to do an inverse norm. Problem is inverse norm only goes below. So when you do inverse norm, that area is everything below a value. So if it's 5% above, then it's 1 minus 5% below, which is 0.95. So we want to do 0.95 because it's doing a lower boundary. And then we'll do our mean, 272 and 9. So when you calculate that, you're going to use 0.95, but when you interpret that, you say 5% of pregnancies last longer than 286.8 days. You would say 95% of pregnancies last less than that, but 5% of pregnancies last longer than 286.8 days. So that's the interpretation. There's your diagram. Again, for all the normal problems for free response questions, you want to make sure you sketch a diagram, indicate that it's normal, have your appropriate inputs, and always do a summary in context.